Good morning, students. We had completed till system of units. Now our next topic is measurement of length, measurement of mass, and measurement of time. As you know, to measure the length, we are using different devices, or we can say apparatus, or we can say instruments. Simply, till now, you are aware with the measure tape and scale, right? Now other devices are also there to measure the things, okay, to measure the length, measurement of the length of the things, okay. So scale, meter scale, then meter tape, okay, measure tape, they are having their certain limitations, okay. If we want to measure very small thing, at that time what is used, very small thing or very big thing, at that time which instruments are used or which methods are used, that we have to learn, okay. Now here, as I said, meter scale, okay, it can measure length from 10 raised to minus 3 meter to 10 raised to 2 meter, right? Means 1 millimeter to 1, we can say 10 raised to 2 meter, okay. Now vernier calipers, it is also other instrument to measure the length, okay, that we have to use in a practicals are there of vernier calipers, okay. It is used to length to an accuracy to till 10 raised to minus 4 meter. Then another thing, screw gauge, okay, it is also known as micrometer screw gauge, and a spherometer, okay, it is used to measure length as less as to 10 raised to minus 5 meter. This vernier calipers, screw gauge and spherometer all will come in practical. I will show you, okay. And if possible, I will send video of this apparatus also. So to measure beyond length beyond this range, we can use some special indirect method. So directly, if we cannot measure, so at that time some indirect method we have to use. For example, to measure the distance between Earth and the planet or star, so at that time that much long measure tape is not available, right? And we cannot measure. Who will go there? Okay. So here, indirect method, that is what parallax method, it is known as a parallax method is used. So the large distances such as distance of a planet of or a star from the earth cannot be measured directly with the meter scale. So here important method, that is the parallax method, is used, okay. So what is the parallax? For that, here example is given. Okay, you have to hold one pencil in front of you, okay, against some specific point on the background, and look at the pencil. First to your left eye, and then you have to see from your right side. Condition is there कि you have to close your another eye, okay. So here we can see A and B. So here you can notice that position of the pencil seems to change with respect to the point on the wall, and this is known as a parallax. This parallax also we have to use in the practicals, okay. So the distance between two points of observation means જ્યાંથી આપણે observation લીધું છે તે બે જગ્યાએથી લઈશું, right? So distance between the 2 points of observation is called basis, okay. So here in our example, basis is what? Distance between the eyes. આપણે લેફ્ટ આઈ અને રાઈટ આઈ વચ્ચેનું જે ડિસ્ટન્સ હોય તે. So now to measure the distance, capital D of a far away planet S, it is denoted by capital D, okay, by this parallax method that is given over here. So here this, in this figure, by using this figure here, A and B, here this is two places from which we have to see the sun, okay. First from A position, then from B position, okay. Capital D is the diameter, distance from the earth to the sun, okay. And small this B is the distance between the two places from which we are taking observations, okay. So again we will go through this procedure. So to measure the distance d for far away planet S by parallax method, we have to observe from 2 points, 2 places, 2 positions, that is observations A and B on the earth, separated by distance small b at the same time. Okay. So now we measure the angle between the two directions along which the planet is viewed at these 2 points. So angle ASB represented by symbol theta, and it is known as a parallax angle as I show you in the figure. Okay. So it is known as a parallax angle or parallactic angle. So planet is very far. So B by D is less than 1, because small b means the distance between the position of two observations, means from where we are taking observation. It is very less than the distance between earth and the sun. So the ratio will be less than 1, and therefore theta is very small. So then we approximately take AB as an arc or length of B of a circle with the center at S and the distance capital D as the radius AS is equal to BS. Understood? So AB is equal to B is equal to D theta, where theta is in radian, angle always in the radian. Okay. So here I explained that two supplementary angles, right? It was radian and radian. Okay. So plane angle and area angle we are taking like that. Whenever it will come, I will explain you. So here having determined capital D, we can employ a similar method to determine the size or angular diameter of the planet. Okay. So if D is the diameter of the planet and alpha is the angular size of the planet, okay, means the angle subtended by D at the earth, we have alpha is equal to D by D. Okay, the angle alpha can be measured from the same location on the earth, and it is the angle between the two directions when two diametrically opposite points of the planet are viewed through the telescope. Okay, so that is the method. Now example number 2.1, it is very important. Calculate the angle of 1 degree, 1 minute and 1 second in radius. Use 360 is equal to 2 pi radian. 1 degree is equal to 60 minute and 1 minute is equal to 60 second. Here you can see, here minute is degree is denoted by okay, and the minute is denoted by single quotes, and second, so here two that signs will come. Okay. So first of all, this is the circle, suppose, right? So here how many degrees are there? It will start with 0. Here it will be 90, here it will be 180, and here it will be 270. So 0, pi by 2, pi, and 3 pi by 2, and here 2 pi. So total 360 degree. How many degrees? So total 360 degree. So we have through 360 degree is equal to 2 pi radian. So 1 degree is equal to 2 pi by 360, that is pi by 180 radian. So its value you have to find out. Then 1 degree is equal to 60 minute, right? 1 degree is equal to 60 minute, that is this one. Okay. So that is this one, right? So now 1 minute is equal to, we have to multiply it by what? 60. So you will get, and 1 second is equal to, you have to multiply whatever you got in 1 minute with the 60. Now another example, a man wishes to estimate the distance of the nearby tower from him. He stands at a point A in front of the tower C and spots a very distant object O in a line with C. He then walks perpendicular to the AC up to B, a distance of 100 meter, and looks at O and C again. Since O is very distant, the direction BO is practically the same as AO, but finds the line of the side of C is shifted from the original line of the side by angle theta is equal to 40 degree. So it is parallax. Okay. So estimate the distance of the tower C from his original position A. So this is the A position and this is the B position. So here what is given? Parallax angle theta is given, that is 40 degree. Now by trigonometric rule, here you can say this is the right angle triangle. Okay. So AB is equal to AC tan theta. Here this is also theta and this is also theta. We know that, right? So AB is equal to AC tan theta. So AC is equal to AB by tan theta from this. So it is 100 meter by 1040. You will get this answer. Okay. So next thing is the moon is observed from the two diametrically opposite points A and B on earth. The angle theta subtended at the moon by the two directions of observation is 1 degree 54 minutes. Given the diameter of earth is given, so compute the distance of the moon from the earth. So first we have to see theta. Theta is equal to 1 degree and 54 minutes, right? So 1 degree is what, 60 minutes. So you have to add this 60 plus 54, so it will become 114, right? So 114 again, if we want to convert it into the radian. Okay, so directly in first sum we have done this. Okay, how we can convert it into the radian? So you have to multiply it by this, because here 1 second is equal to, in first example we have done, that is 1 second is equal to this 1 radian. So first we have to convert this 144 minute into second, then we have to multiply it with this to convert it into the radian. Got it? So now next, here B is equal to AB is equal to also given, right, diameter of the earth. So D is equal to B theta, you will get this. Okay. Now next, the sun's angular diameter is measured to be 1920 second. The distance D of the sun from the earth is this one. What is the diameter of the sun? Same thing you have to use. Sun's angular diameter alpha is equal to 1920 second. You have to convert it into the radian. Okay, so you will get this, and then you have to use this formula. You have to finish this till 2.4. Okay, then I will continue in the next video.